Hey guys, this is Dustin. Welcome to this presentation on the R programming language. In this presentation, I'll talk about general information about R, the history of R, the paradigm of R, the data types, operators, control flow, some applications of the language, and then we'll have our conclusion and our references. R is actually an implementation of the S programming language. If you have some code that was written in S, it's highly likely that it will run in R without having to change anything. R has lexical scoping inspired by scheme. What that means is that if a variable's definition is needed, it's resolved by searching its containing block and then the next containing block, and so on until the definition is found. R is a high-level language, meaning that it's really simple and easy to understand. It's closer to English than it is to machine code. R is widely used for statistics. I saw it for the first time in my statistical methods class, and it's pretty useful and impressive, honestly. R is ranked number 18 by the TOB index and number 9 by the PYPL index. The difference between these two rankings is mainly due to the fact that the TOB index basically searches how many pages contain the keyword R programming. PYPL, however, keeps track of how many different visits are on the page. So TOB just keeps track of how many pages have it, but PYPL keeps track of visits. Here's a graph demonstrating the growth rate of R compared to C++ and Java. R was created by Ross E. Haka and Robert Gentleman of the University of Auckland in New Zealand. They originally intended for it to just be a teaching tool for use in their classes, but Martin Mockler encouraged them to release it online. The R source code was originally released in June of 1995, and I thought it was kind of cool that originally it was updated via a mailing list, so they would just email out their bug fixes and updates and everything to everyone that was on the list. R is now maintained by the R core team, of which Ihaka and Gentleman are still members. Something else that's kind of funny is that the developer of S, John Chambers, is also on the R core team. It's like he jumped ships. The paradigm of R is a combination of functional, imperative, and object-oriented. It's functional because R uses lazy evaluation, which means that expressions are only evaluated as their values are needed. It's imperative because of the lexical scoping that I talked about earlier, and also local variables can be updated. It's object-oriented because it highly depends on the use of objects. The data types in R are logical, numeric, integer, complex, and character. All of these are pretty self-explanatory, except for the integer. The L's basically just guarantee that when the variable is stored, it's definitely an integer and not some other value. A cool function in R is the class function. If you put a variable into it, it'll return what the data type of it is. Here's a demonstration. R has 5 different data structures built into the language. First, there's a vector, which is one-dimensional, and all variables must be the same type. Then there are matrices, which are basically the same, but they're two-dimensional, so all the variables still have to be the same type. An array is like a matrix, except it can go up to any number of dimensions, and they still all have to be the same type. A list is like a vector, but it's more flexible, because you can mix the types of elements, and you can even include a vector as an element in a list. Data frames are really useful in R. They're basically a list of equal length vectors. So if you had your input X and your output Y, and you wanted to keep them associated with one another, you would use a data frame. R has 3 different assignment operators. The equal sign can only be used top level, That means you can only use it in the command prompt. The arrow can be used anywhere, and the double arrow, you'll usually only see that in functions. It causes a search through parent environments for existing definitions of variables being assigned and then redefines it. If it doesn't find a definition, then the assignment happens in a global environment. The arithmetic operators, you have your addition, subtraction, multiplication, division, and then you have two options for your exponentiation, and then you still have modulus, so 5 modulus 2, that would return 1, and then you have your integer division, so if you did 5 integer division 2, then you would get 2, because 2 goes into 5 twice with a remainder of 1. R also has all the logical operators that you expect to see, like less than equal to, greater than equal to, is equal to, not equal to, and you have the negation operator, so if x was true there, then you would get a value of false because of the negation operator. And then you also have the or symbol and the and symbol. Control flow in R is pretty simple. It's just like C++ or Java or anything else you're used to. The only real difference is that here, this control statement, you have a variable in a sequence, and for the sequence you would put, say, 1:10, so it's a variable in a sequence from 1 to 10. You can do a for loop all on one line, just as shown here, or if you have multiple expressions that you need to operate or complete, then you'd use the curly brackets just as you would in C++.